Well, here we are. It's a Thursday. It's time for another Golden Path to Spring One. Matthias, thank you so much for joining us here today. I really appreciate it. I should turn on my light so people can actually see me. That would be smart. This is what I don't like having them just blare on me all the time because they're so bright, so much light. But I guess it's fine. Well, I
Can
don't know,
you
maybe
see
it's
me
a
well?
plus. Maybe it's a plus. You look great. You look fine. You look fine.
Thanks.
Well, thanks for hanging out with us. I appreciate. I know it's evening for you, so thanks for sticking around here. I know for me it's just I guess early afternoon. We would call this just after lunchtime, something to that effect. But thanks for joining us. What are you going to talk about today?
Well, first of all, thanks for having me and doing all this. It's great to be part of that. It's not live and in San Francisco as we all hope, but still, it's better than not doing things like that at all. So, yeah, what I'm gonna talk about today is a topic like in a generic way about how to implement or what are the various technologies to implement distributed systems or like microservices as a special form of distributed systems, which we see very often nowadays, and trying to compare various approaches, how to, and basically, first of all, identify why you would do such a thing as distributed systems in the first place. And if you decide to do that, what are the things you might want to have and need to be successful with it? And I'll try to compare various approaches from starting on an application level, then in a cluster level, and on a network level, and just give an impression what I currently see as technology options out there, and maybe try to raise some inspiration or attention to that.
Heck yeah! And as I said in the pre-show, I love your hoodie. I love your hoodie. I'm
Yeah,
very fond of that.
yeah. This is I had to dig this one out. It's a bit too cold just to wear a Spring One platform T-shirt, but I think it was the
Fair
one
point.
from Washington where they gave out hoodies.
I think so. I can't remember exactly when that was. Maybe Deshaun remembers. So Deshaun's hanging out here. Good to see you, Deshaun. Deshaun's ready. Deshaun says it's going to be amazing. I know it is as well. Why don't you go
Hey,
ahead and share
Sean.
your
Good to
screen?
see you too.
I'll add that into the the stream here once we're ready. But yeah, I'm going to limb and say, is Deshaun going to ask a really good question today? That'll be interesting to see.
I'm kind of afraid of his questions, but no,
Maybe. I don't know. I feel we'll roll it. We'll do it live. We'll do it live, as they say. So,
All right.
Well, you got some slides. You maybe even have some code, if I remember right. Oh, Simon, our super commenter is here. Hi, Simon. Good to see you again. And we've got
Yes, Simon.
another. I like the icon. I'm not going to try to pronounce that because my brain will probably have a problem there. But we also have, it was funny on Tuesday. We had folks from everywhere. We had folks from like India, and we had people from all over the place. So always fun to see who's willing to hop on a call with us at odd hours of the day.
Right. Okay.
All
So
right.
hello everyone to wherever you may be in the world and whatever time it is for you. Thanks for joining.
All right. Well, you got to hit present on your screen share, and then I will add it into the mix. Oh, yes, Deshaun, Kansas City, Missouri. Yeah, we know. You're just south of me. It's all good. You have better barbecue than I do, so yeah, you got that going for you. Although I will say, Deshaun, I found a pretty decent barbecue place that if you're ever in the Twin Cities, I will definitely take you to. So,
all right, I'm gonna join you guys.
Yeah, absolutely. You're more than welcome to join us. It was quite legitimate. We ended up there randomly one evening, just kind of almost on a lark, and because I'd heard stories, but it's a little, I won't say out of the way, but it's not in a super obvious place, and so we drove there one evening, and it's like, this actually is very, very good. So I'm pretty proud of that. So okay, Simon, I didn't know you were from Belgium. All right, good to know.
So at least there's one in my time zone. So thanks for staying up late. I totally appreciate that.
Exactly. Oh, and Bavaria, I like that.
Oh, Harry. Nice. Okay, I know him.
Okay.
So
always good to have some plants. That's right. Always good to have a couple plants in the audience. So I see you've got our StreamYard up in your screen share. If I share that, we're going to get the beauty of the infinite screen. So we need to see that. There we go. That's better. Let's see what happens. Let me click that, and boom, there it is. All right. Well, I'm going to drop here and let you have at it, my friend. I know we talked about this before. If you have questions, throw them in the chat. We'll do our best to interact with them as they come up. I may reappear if there's a particularly pressing question. Otherwise, I'm just going to leave it to you, Matthias. So enjoy, my friend. Cheers.
All right. Thanks a lot for the lovely introduction. And yeah, again, thanks everyone for listening. As you can see on the background of this title deck, this is the Sagrada Familia in Barcelona. And this was basically the background for when I did the first draft of this presentation. It was for Spring I/O in last year, and it's going to be happening in, I think, 3 weeks again. And I think Deshaun, we're going to see each other there, so definitely looking forward. So what I'm going to talk about today is, yeah, distributed systems, distributed architecture, basically, yeah, the nature of distributed applications, what kind of advantages they bring, and what kind of like requirements they will have in order to master them successfully. And I'm going to compare various options to approach that. So my name is Matthias. I work for a company called Novatech. I actually, below my Spring One hoodie, there's the Novatech logo, so everybody should see that as well, maybe, so that my manager is happy with me too. All right, so I'm gonna dive in here. Yeah, that's me. Another photo. You will find me on most social media platforms. I have LinkedIn and Twitter in there at the moment. I've actually joined Blue Sky just the other day, so I got a similar, like pretty much the same handle as in Twitter, so you'll find me there as well. My role at Novatech is called Chief Technologist, so I'm kind of dealing with many different technologies in the cloud native space. And I try to understand them myself, and then whenever I do, I try to help pass this information on to others. Others could be clients, others could also be students. What some people probably don't know is that I'm also a university teacher in the field of distributed systems and modern software architecture. And that was also kind of a bit the fundament of this talk. So when people talk about distributed systems, especially in a context of university, it sounds a bit like an old and gray and dusty topic. So what I try to do in order to make it more attractive to my students and also to gain insights into those technologies for my daily job is doing distributed systems with modern technologies and keep a strong part on the hands-on side of things. And yeah, here you can see 4 technologies that I would certainly consider as modern. And these are basically the things we're going to talk and look into today. So yeah, as this is the Spring One, of course, Spring Cloud takes a certain part in it. I think actually that the title of this one was also more like on the topic of eBPF. So how does eBPF relate to all those things? So I'll try to get them all into kind of a relation for you. And again, I don't like this kind of top-down teaching and only one person speaking. So if you have any questions throughout, whenever, feel free to interrupt me. And yeah, I think Nate will let me know. So I love to answer questions right when they come up. And if I feel it doesn't really fit into the point where they are now, I might push them to the end, and we're going to talk about it then. All right, so let's start. I'm normally a big fan of starting with why. I kind of explained already why I created this talk, but also then I want to go into why distributed systems and why would people do this in general. And then on a like rather theoretical level, how do you do that? What do you need? And from that, we're going to look into various options like frameworks like Spring Cloud, Kubernetes, service meshes, eBPF. I hope to come to a conclusion then. Maybe I can show some of those things live, but it's I haven't prepared a demo in particular. So I've just been teaching a class on Kubernetes today, so I might show you some things within the cluster there. But the focus is more like on the visualization in the slides here. Yeah, now why would people do such a thing like a distributed architecture? I mean, in the end, whatever we do with IT and software, it's most likely to make the consumers or the clients happy. So in the end, even if a system is very distributed, people should never see that. To the consumers, it should appear as like one system. And they shouldn't see what's behind that and just basically consume the functionality without worrying how people would implement that. Now, a couple of reasons why people would potentially say I'm breaking a system from one piece into many pieces, or why a nature of many pieces would come into existence, is the factor of heterogeneity. So things can in a certain way be different by nature and not being able to run in the same system. So one of the things, a high level thing could say, okay, I want to run different tasks. I might want to run them in parallel, or I just want to like spread them out into individual components that they don't interfere with each other directly in one machine, or basically to create some independence in that. Another thing could be on a lower level, that is, say you're running certain applications might require certain underlying operating system requirements, running on a mainframe or Windows, Linux, whatsoever. And the sum of things would bring the functionality of the overall system. We could take this a level higher and say it might not only be the operating system, but it might also be the framework and the application. And this is, for example, I've put other frameworks here like Quarkus or Micronaut, Spring Boot. These are all Java-based, so obviously I'm coming from the Java side of things, but it doesn't have to be a cut down to that. So in the end, in the microservice world, one of the important aspects is to enable a polyglot nature of things and being able to use the right programming language or framework for a certain task. So these are kind of architectures that I get to see very often in my daily job. So narrowing it down to even Java or a certain framework, it still might be the same level and don't have the compatibility of that. So that still might mean that you have to run separate components because you have variations in the versions. This is actually a feedback that I got from one of my students, and I added it to the slides, which surprised me quite a lot. He said, you might want to distribute the system also according to individual development teams, which is absolutely correct. We don't really want the development teams to be too big and be able to deliver individual components from a reasonable team size. Finally, we also might want our system to grow over time and add components to it. And with that, we don't necessarily want to like rebuild or stop and redeploy everything over and over again whenever we add something new. So all those kind of things are pretty much on the side of the heterogeneity side. The other big aspect or the big category that I see is the factor of resilience or robustness of an overall system. So with the possibility to running multiple instances, you can also create a level of redundancy. So your clients won't see if they're like 2 or 10 instances. And if one of them fails, your clients shouldn't see that as well. So this could bring you further towards better user experience and less downtime. What comes along with that very often, if you have multiple instances, you might also want to do load balancing of the traffic. So if your clients grow, you're able to handle more loads without the system going down. On the other side of things, if things get too bad, so either your clients grow exponentially or also in a bad way, if you have some malicious attack with too many requests, a distribution might also help you to block traffic and prevent your system from getting damaged and keeping it high available with potentially a temporarily controlled outage, much rather than things are breaking down and you have to recover from such an outage. A certain subform of that is rate limiting, where I say, okay, I can control the traffic, and maybe for some of the components of traffic might be too much. So I only let the traffic through that I know that the system can handle. Security, of course, is a big topic in here as well, that if some have requests entering the system, you want to make sure these have all the the rights and privileges to access the systems as they are supposed to be. Finally, or it's probably not all of the reasons, but I'm coming pretty much to an end with this, is also the high availability factor of an application is also that you don't need to stop it or interrupt the service if you roll out new versions. So in a distributed environment, you can of course say you deploy a new version just like right next to the original one, and then switch the traffic whenever they think the time is right. A more advanced version of that is called canary deployments or percentage routing, where you have fine-grained controls to say, yeah, I want to do like only a little percentage on the new one. If it's going to be good, then I'm going to increase it, or I'm going to like inspect the traffic if there are any cookies that have been set. So only those ones I'm going to route to the new application, and so on. I just had that, I think, with Google News recently. They rolled out a new version and they asked me if I want to basically have that new one. So basically, in that case, a cookie is being set. And whenever I open the page, I'm going to be routed to the new version, while other people might still access the old one. So that's kind of a real-world example for that. So that's probably not all of the things, but that's all the things that I have kind of listed here now. But I think it gives a pretty good impression of why, in some cases, it might make sense to step away from a single point of application to something which is distributed over the network, and different components basically taking different roles in that system. So what do you need to do to get there? I mean, obviously, as I said it, you need a network. So that's pretty easy, and you need a communication protocol that each side will understand so they can talk to each other. In order to talk to each other, those services also have to find each other. In order to do that, you need some kind of a telephone book for those services, like a service registry, where the services can say, hey, look, I'm there. And then other service can say, well, I'm looking for service X. And then if there's a record, they get the information how to access service X. And another requirement that comes in with if you distribute the system is, of course, to say, if I roll out a configuration, and I want to roll it out to either all parts or more than one part, then I need the mechanism to distribute the configuration to those pieces that I really want to. So this is called, goes under the umbrella of distributed application. And finally, we also have observability. Distribution makes systems more complex and harder to observe. So it's very important to say, okay, I know what's going on in the individual pieces, but I also know what's going on in total, and I'm able to identify and isolate problems once they arise. So in the end, a lot of the things naturally comes down to the network, and you need to be able to kind of interact and modify the network traffic. So I put this in as a kind of a routing traffic shaping component, which does a lot of the things that we have just seen. So it can route the traffic to certain destinations. It can distribute the traffic across multiple nodes. It can throttle or even block the traffic. So this is kind of a component we will probably see over and over again in many different ways and many different implementations. So I kind of sketched this out as a typical small-scale example of a distributed environment. So basically I have 4 services and then some databases or backend system. On the left side, I have like an API gateway or proxy that kind of lets the traffic into the system. And then we have the things we talked about, like service registry, distributed configuration, distributed observability, to round it all up. And as you can see, it gets complex pretty quickly. So we only have like 4 services here, but it doesn't get simpler once they get more. And then we can start trying to think of those things that I said before, like I want to scale up that service D to multiple instances. I want service C to load balance over them. With service A, I want to do like dynamic updates and run multiple versions in parallel and things like that. So these are all the possibilities that I'm going to get out of this. So stepping away a bit from the theory and more onto implementations of that. I mean, one company that had exactly those requirements because they had a very distributed landscape and by nature, a distribution of applications pretty much around the globe is Netflix. And of course, there was also a need to serve a decent service level. Otherwise, people would probably not watch it. So Netflix back in, I think, 2015, I wasn't around in that space back then, but from my research, it must have been around that time, had an open source suite, which basically had a couple of components in there to exactly address those challenges. It's like a Eureka as a service registry, something Hystrix for resilience mechanism, ribbon load balancing, and so on. So I still found some artifacts around that. And if we think back about that traffic kind of shaping component, you would see that in different aspects there. So in the API gateway, you would potentially route and probably do other things. On the ribbon side, you would distribute the traffic and enable load balancing. With Hystrix, you would do things like blocking or throttling traffic in case of like in a circuit breaker or bulkhead kind of style. And so you were able to place the individual functionalities of such an implementation right into the spot where you would actually need it in your landscape. Now, we have almost 30 slides in, and I finally mentioned the word Spring again. So the Spring Cloud approach kind of originated out of the Netflix approach. So I think a couple of those projects were done with engineers from either side. And as you can also see from the naming, a lot of the concepts of the Netflix original products were taken over. So in Spring Cloud, there are things like Eureka also as a service registry, or config server, Zipkin and Sleuth for observability, Hystrix, Resilience4j for resilience mechanism, Ribbon and Feign for load balancing and REST clients. Then Spring Cloud Gateway, or the initial version with Zool as an API gateway. So with that set of tools, you're pretty much able to do all of those things that I initially listed as these are requirements that you need to have to build such a system. So the way they work, and I guess this is what probably most people listening here are familiar with, is that you, if you build your Spring Boot application, and for example, you want to define a Eureka server, what you need to do is put a dependency for the Eureka server in your POM XML or in a according Gradle style, if you prefer that, and just put an annotation in your code to basically make Eureka up and running and listening for joining services. On the other side, if you have applications that want to join Eureka or want to basically consume Eureka as a telephone book, then things are pretty similar. So you need dependencies again, you need to do some changes in the code, and also some configuration. And in this case, the configuration specifies the name of the service under which this service will get registered in Eureka, and then can also be found by other services within that distributed application space. So I'm not going to go over each and any of those things, but the point that I'm trying to make, if you use that approach, then you certainly have a change or modification in your code. It's not a big change, and especially Spring Boot makes that very, very easy to use little code in order to get things up and running. But the level of change in order that you need to do is on code and configuration level. So this is another example for the Spring Cloud Gateway. In this case, it's more like only the dependency and the configuration, which in this case would say, okay, if a certain request comes in under a certain path, then basically forward it to that URI, which should be something within the environment that the gateway can access. So that means you have all those things running as a part of the actual process of your distributed component. So this brings the advantage that you are totally independent on wherever your process runs. So that basically means they could all run as distributed processes on one machine. They could all run on distributed processes on many different machines, as long as they are connected over a virtual network, they could all run in containers. It totally doesn't matter. They're just required to access the network and basically find their peers. So that makes them pretty flexible and totally independent of any kind of framework or runtime. So this is kind of repeating what I just said. And yeah, I probably got to re-emphasize on the point on the bottom. The big advantage here is also that you don't say, okay, I need to enable all of the service with any kind of potential configuration. I can basically pick and choose and say, okay, they should all be part of the network, and so they could be clients of Eureka, but not everyone needs to have like Hystrix functionality. Not everyone needs to maybe have ribbon functionality. So I can pretty much pick and choose and say, this is what I need, and I can define on myself what is the level of footprint that I actually going to bring into that system. All right, so now from standalone framework, we kind of switch focus towards Kubernetes. I mean, this is something which has become pretty popular in the last years. I'm just coming back from KubeCon, and I'm still pretty impressed of all the things that are going on there. And yeah, Kubernetes basically, I won't be able to explain it in 5 minutes. So I kind of assume a high level understanding. So the way I would probably explain it, as we have seen before, those services can run in containers. Within Kubernetes, things running in containers as well, but it's more like in a way that you have a distributed container daemon. So you basically have a distributed landscape, both on the workload side, but also on the infrastructure side, which makes it flexible and dynamic on either end. The thing you should probably hear of and get familiar with is the term kind of a pod. A pod is basically the smallest unit of deployment in Kubernetes. And to make it easy to think about, just imagine a pod like a wrapper around a container, which is Kubernetes kind of vehicle to run those containers. Now that means if we have built all of our services with Spring Cloud, they would run in Kubernetes in the same way, just alike. As long as they can connect to their other services, it would certainly work. Now, the thing with Kubernetes is Kubernetes was basically designed to fulfill a similar job. So Kubernetes was designed to run distributed applications and facilitate them with all the needs or many needs that people would potentially have with that. So as you can see in this chart, Kubernetes, for example, comes with an own service registry. It comes with an own concept for external configuration. There are plenty of options for observability. And there's something like an ingress for inbound traffic, a deployment where you can basically say this one can take care of switching between versions of an application. You have replica sets for scaling and services, which are probably going to go in first as a component that fulfills already two roles. So a service on the one hand side registers an application in the service registry, so it can be looked up and accessed. But it also does load balancing across all the instances that are available of a certain application, of that respective application component. So when we look, the way things are just being done here, and that's probably not a big surprise, is in YAML. So in here you write your configuration in YAML. So over here you can see we decide we're gonna have 3 replicas of an application with that label. The application is being registered in the service registry with that label. So whenever somebody invokes that, the service will take care that the load is basically distributed across the instances of all of the instances that have that label. So looking back a little bit towards Spring Cloud, that of course means a lot of the things that I showed before kind of become obsolete in here, because Kubernetes already provides that. And then, of course, you don't need to have things twice. Another aspect that I didn't show yet is like the configuration aspect. So it doesn't provide a thing like a configuration server, but it provides objects like config maps and secrets that can be externalized from your application component. Then you can inject the configuration in kind of a 12-factor style. Now, yeah, so looking back, if you already have started with something like Eureka, you're probably not going to need it again. I mean, you probably don't need two different kind of service registries in one cluster. So what Spring Cloud provides in that case is there's a thing called Spring Cloud Kubernetes. So this is basically kind of a very helpful framework for people adapting to Kubernetes, but that already have been using Spring Cloud before. So the simplicity it has, you can basically just exchange a configuration from Spring Cloud Eureka to Spring Cloud Starter Kubernetes. That means you don't have to do any changes in your code, really, or only minor ones. And in the end, this dependency will just swap out the Eureka service registry with the Kubernetes service registry. And that means you can still use it in a very similar way as you had been using it before, as you had been using your service registry before. Similar thing goes for configuration, where you can use your configuration property style in your Spring classes as before, but then they're going to be mapped to config maps and secrets out of a Kubernetes definition. So this comes in fairly handy. And as a summary, you can basically say Kubernetes provides a lot of things out of the box, totally independent of what framework you have. So it works with Spring Boot, of course, but it works with many others as well. It's kind of independent of that. So you get out of the box functionality for scaling, load balancing, service registry, and that. The part where it's basically not comparable is in advanced network and resilience patterns. So something like that was, as we've seen from Hystrix before, is something that you won't find in plain Kubernetes. Also, advanced routing between components or blocking traffic, securing traffic, and so on is something that you will not get out of the box. Again, if you come from Spring Cloud, you can use Spring Cloud Kubernetes, and then you have only minor steps to do in order to adapt your code. If you start from scratch, it's basically your decision if you really want to use it at all. All right, so coming from that point to say, yeah, there's something that we miss here in Kubernetes. How can we address that? And one of the things that tries to approach this is the concept of a service mesh. So I'm just going to sip the drink. So I said before, the base unit in Kubernetes is a pod. And by nature of the thing, but normally one pod is basically holding one container. However, potentially, and this pod will be bound to the Kubernetes network traffic, potentially you can put more containers into one pod. That's basically why a pod was initially created. And they would start sharing many things. So they would start sharing the same file system. They would be running on the same host. They would be, and this is the important part, they would be sharing the same network. They would actually share the same IP and have a common port range. So that means that all of the network traffic that one application container would see is what the other one could see as well. This doesn't make a whole lot of sense to put multiple application containers into one pod, because then they would either go down and go up and down together, and you couldn't scale individually. But the fact that they share the same network can be used in a different way. And now I'm coming back to that network proxy component that I've talked about before. In this case, this will be put as a sidecar proxy into your pod. That means it will be able to observe all the network traffic that goes into your application, but it will also be able to react on that. This isn't so super helpful if you do it only for one, but if you do that for all the pods in your environment, then you're not able to query all the traffic. You are also able to summarize, aggregate, and evaluate that. So hence the name service mesh, where you kind of get the combined traffic and service and information of all your services in your environment. And you can't, and it's not only about just looking at it, you can also modify it and apply certain policies and rules. The other advantage is it is totally independent of the actual application pod. The actual application does not need to be rebuilt or recontainerized or whatsoever. It actually doesn't even have to be taken out or stopped within the Kubernetes environment. So it's just going to be the sidecar pod gets added, which will then trigger one restart. But after that, the application container will just continue doing its work. Actually, the application container wouldn't even know that there is a proxy inside. So that makes it pretty flexible to say, okay, I can use this for whatever application types. It's totally agnostic of the application type as it operates only on a network. And the other advantage is you can very easily swap it in and out because, yeah, as I said before, your application doesn't need to be modified. So this makes it pretty easy in a way to say, I'm going to try it if this works for me. And if not, I'm not going to use it. All right. So what can you do with those things then? So imagine you have full network control over all of those arrows here. First of all, you need to enable your Kubernetes environment with those sidecars. So that means basically your pods are going to get larger and you put all the proxies in anywhere. And here you can already see basically a part of the problem. This will, of course, generate a bit of overhead as it's not only in every application, but literally in every instance in order to query all the network traffic. But then all of those traffic, of course, needs to be collected and summarized and sent to a certain control plane to deal with it. In this small example, you can all probably see why this is being referred to as service mesh at some times. You need to be very careful when you set this up. But then let's talk about the advantages. Now you can, of course, say, I want to encrypt or secure the traffic between those two components. And those two proxy components can be configured to especially take over that part. Also, and then you can say, okay, this is a simple way of such a rule. It's not encrypted, but it's just basically making sure that this destination component will only accept incoming traffic from something with a source label of a certain type. Another thing you can also do is granularly split the traffic or do, if you do like a canary deployment, say this is the percentage of the routing that I want to do, and I'm going to configure it in a way, and also I'm able to change that percentage while the proxies are active without any restart. So I'm always not sure if people need all that functionality, but these are all the possibilities that you basically get out of it. Again, here, this is basically the YAML example where you can say, okay, this is the weight of my routing. It's like 75 and 25% here, and this can be updated and patched dynamically. Of course, also, all of the things are being implemented as Kubernetes objects. So you can, of course, put them into the same code repository and version them in the same style. Now, if you look back at what Spring Cloud Gateway kind of provided initially, so as an API gateway, so you have opt-in, canary style, fault injection, circuit breaker, retries, and so on. So I'm not going to read through all of those. And this is very similar to what Spring Cloud Gateway also provides, basically using as an API gateway. So technically, that's kind of what it is. You kind of inject the full functionality of a gateway into each and every component. And that's a pretty strong difference to what we did with Spring Cloud before, where I said, okay, here I only want to use that functionality, and here I only use that one. With that approach, you pretty much get the full footprint all over, no matter if you really use it in all that way or not. All right. So a certain nice side effect of that is not only about to be able to shape and protect or like secure the traffic. Another factor is also observability. now that you know where all the services, how all the traffic flows, it's pretty easy to render that and display this. This, of course, can be like very helpful in an environment where you don't really understand what's going on. And here you can see the flow of the traffic. I mean, this is a pretty simple sample of one of our exercises in our class. So in that kind of a style, you probably would not need a service mesh. But again, if you do, this shows it in a simple style. If you do some traffic splits, you can see, well, this one gets the version 2 gets 80%, version 3 gets almost 20%. And then you can see how that gradually moves over. It's at least nice to look at. When it comes to more sophisticated applications, this is, for example, some of you will probably know the Spring Pet Clinic. And this would be the corresponding output on Kiali, which is a visualization for the Istio service mesh, where you can see it comes out pretty similar. You have the gateway here, you have the various services. So this can also be used, of course, to validate, are things going the way I intended it to have? And from my experience, this was also very helpful to show it to customers. I mean, not many people will be able to understand like a kubectl output from scratch. And they probably wouldn't believe it all the time, but showing things like that will certainly help to make people understand what is currently going on. Now, if this is also great, why don't we do it all the time? There are probably two sides to that. First of all, and this is definitely something which is important, is the overhead. I mean, you have this sidecar component in every pod, which by nature brings some kind of a consumption of CPU and memory all across your cluster. Even more so, it's probably about the latency. I mean, by nature of things, if you connected from A to B before, then you will basically from now on connect from A to proxy A, from proxy A to proxy B, and from proxy B to B. So there's additional network hops in there, and whatever they do with the traffic, they would potentially slow it down even more. So this is a benchmark which has been done by the CNCF, the Cloud Native Computing Foundation, comparing Linkerd and Istio to of the most popular service meshes out there. And I don't want to get too hung up on which percentile does what, because this always depends on your configuration or on your applications and how many services you have whatsoever. But in some, I can just say there will be a noticeable difference. And this is something you should evaluate first before you take this to any further steps. All right. So again, on the positive side of things, you can easily swap in and out. You don't need to modify the application. The configurations are changed at runtime. However, you pay the price for injecting the sidecar proxy into those pods, and by that you would get the control over the network flow. So this can, of course, be seen as a logical extension to Kubernetes, which bridges the gap that Kubernetes leaves on the network segment. Now, finally, let me look at the time. Yeah, got a few more minutes. There's eBPF, and it was definitely one of the hottest topics from my KubeCon experience last week. And this is pretty impressive because I think about a year ago or 1.5 years ago, people might have not heard about it. So in the meantime, there's a big hype around that. But I still think a lot of people don't really know yet what it all is and what it all can do for you. So I'll try to summarize it very briefly. I'm not like a deep level expert there either, but I've been playing with it for a while, since I have heard it for the first time, because I think there's quite a huge potential in there. So the name actually stands for Extended Berkeley Packet Filter. So even if you read that 3 times, it probably doesn't sound like distributed systems or service mesh or anything alike. It is actually a very low-level Linux functionality. So we're taking a step away from Kubernetes now and looking at a Linux machine where you say, there's a kernel space where like the kernel software runs. Is normally a very protected environment and very difficult to change. All the changes and things the user do should actually be happening in the user space. Now, eBPF kind of changes that a little because it provides something called an eBPF Sandbox. And for me, the most helpful explanation was this is basically comparable to what JavaScript is in a web page. This is what the eBPF Sandbox is in the Linux kernel. So it can run custom code in there, but it doesn't have the possibility to do any harm to the environment. So that sounds pretty good. So what can it do in the kernel space? It basically can interact with kernel events, and one of those kernel events are, of course, network events. So basically, that gives the possibility to interact with those network events on a very low level. Then later on, it can send that information to things in the user space where it can be processed with different SDKs, libraries, or tools. So why is that so important for us? If we look at Kubernetes again, most of you probably know that Kubernetes runs on one-to-many so-called worker nodes. This is the place where you have your Kubernetes setup and the containers on top. But on the bottom, you also have like an operating system. And this operating system happens to be Linux very often. So now this kind of closes the loop and saying that basically means we can use that eBPF functionality on any of the worker nodes in such a Kubernetes cluster. So this is a similar thing as we have seen before with the pod-based service mesh. You basically have a control plane where all the things are being aggregated and things are being worked with. But then you have like the data plane, and in this case, the proxies or the agents, or whatever you want to call it, are not sitting in the pod of your applications, but they're sitting on the nodes of the cluster. And they're interacting with the traffic on that level. So by first impression, that of course means you will most likely have way less nodes in your environment than you will have pods. And so the footprint that it leaves is, of course, different than if you have a pod-based environment. So looking again at this diagram, what does it mean in a very simple form? So we used to have that proxy component somewhere in the application code. We used to have it basically in here within the container, within the pod, and now we have it on the nodes. And now we can do very similar things to say, okay, I'm applying a network policy and say, okay, this one goes from has an endpoint selector, again matching labels, which allows it to route the traffic to another component. So this, of course, suddenly has control over the network of the entire cluster, and you can do almost similar things that you can do with a proxy based with a pod based service mesh. So this slide is already also like a year old, but I found it still very interesting because the Cilium is a company that implements this eBPF, is a technology that implements that technology of eBPF. And when they started building that Cilium service mesh and put it into a beta program, they asked a lot of people, what are like the most interesting things that you would expect from a service mesh? And we basically see a lot of those things again that I talked initially about, what you would need for implementing distributed systems. So like rate limiting, circuit breaking, retries, routing in various ways, canary rollouts, encryption of the traffic. But surprisingly, the number one feature that people really wanted to have is observability. So this is the way how Cilium, I think, built the beta program of the service mesh. Like now it's fully released, and I think it can do all of the things. But over time, they just added more and more features in that order that how people wanted it to have. This again is a screenshot of what the Spring Pet Clinic looks like in an eBPF style of visual, like an eBPF source of information and visualization on top. So yeah, by surprise, it's the similar things, visit service, vet service, and so on. And again, it can help, of course, to get a bit of an idea of how the traffic flows and what's going on in my cluster there. All right. So to sum things up, I mean, this injects the proxy component on the node instead of the pod. And it really interacts on low level Linux style. So early stage of development is probably not true anymore. So especially the Cilium project has gained a lot of traction. They have come up with a lot of improvements over the last year. So this is definitely production ready in the meantime, and it's already adopted by many of the vendors to be built in their Kubernetes cluster just basically straight away. So how it turns out in terms of latency and also in terms of a parity of functionality compared to traditional service meshes, this is still open. But the evolution is pretty fast. And we'll have to see what's going to come out of this. So in the end, to wrap things up here, there are different options, and there is probably no real right or wrong in which way you approach. It will always depend on kind of what application frameworks are you using, what kind of requirements does your application have. But the good thing for you is there are options. So in a Spring environment, you can basically say, okay, I'm going to use Spring Cloud, and I don't care what the surrounding is. I mean, this is something I probably haven't mentioned explicitly, but of course, service meshes and this Cilium technology, they in that way, they only work with Kubernetes. Or they're based on the thing that they are running on the node of a Kubernetes worker. That is different if you build your functionality into your code. We've seen what Kubernetes does out of the box with sidecars and with an eBPF level. So right at the moment, it's really difficult also for me to see what the future will bring. But I totally think this is a very interesting development. And the various technologies are kind of pushing the boundaries, especially that eBPF technology opened a lot of things. I mean, there's more into that we have just shown here. Just imagine of automatic monitoring agent configuration, or like observability metrics that you can get out of this that go beyond just like standard network connectivity. There's a lot of things on the roadmap, and I find it very interesting to follow. What's next? Hard to say. I've introduced Istio as a pod-based service mesh. Last year, they also announced a thing called Ambient Mesh, in which says a new data plane mode for Istio without sidecars. So maybe this new evolution brings a lot of dynamic into the development of other technologies as well, where in the end, we as consumers will hopefully be the winners then. I'm not going to go into detail how that one works. And to be honest, I haven't played with this very much yet. You will find out more on this on the Istio website. Anyway, this kind of brings it to an end. So yeah, I almost talked for an hour. This is more than I wanted to. So definitely thanks for listening to whoever is still there or who has joined in the meantime. Feel free to connect and reach out to me. And now I would like, if you want that presentation, if you liked my slides, you can certainly download it from here. I'm going to update the versions every now and then. And yeah, that's that. So
awesome. Well, thank you. Here, I can remove that, and then it'll just be the two of us again. Thank you so much. So I wanted to highlight a couple things here from the comments. First of all, Simon said, and I clicked on the wrong one, great drawings in your slides. I completely echo that. Thank you, Simon, for bringing that up. Agreed. Very, very clear. And Deshaun chimed in, wonderful insights, and says thank you very much, as did Simon. So thank you very much, Matthias. I really appreciate it. That was awesome. I'll give a quick moment. Does anybody have any questions, anything they want to ask before we wrap up here? Give folks just and while you're doing that, let me go ahead and mention a couple of quick things. First and foremost, you brought up Spring multiple times. I've actually got Pet Clinic open here to my right, ironically enough. And I want to point out we've got Spring Academy. If you are open, let me hide that comment so that we get rid of that so we see the whole thing here. We got Spring Academy, so if you're looking to learn more about Spring, you can certainly do that with us. If you're looking for certification, we can make that happen as well. And here's hoping that we'll see some or all of you at VMware Explorer in Vegas in August. I know, Matthias, you and I were talking about that a little bit in the pre-show. I was looking forward to actually seeing you in the real world in San Francisco. Sadly, that did not happen. But here's hoping that we have an opportunity here in August.
Yeah.
So, fingers crossed.
Some of your colleagues have asked me already. Unfortunately, this kind of collides with the German summer vacation, and I have two kids. I mean, I might convince them to do the vacation over in Vegas, but I can't promise that yet. So I have it in the back of my mind. We might be able to see each other there.
It is family friendly now, or so I'm told. It's been a while since I've been to Vegas, so
right.
What kind of trouble that gets us into. One other comment here from Harry saying it was awesome. Great session. Glad he was
Thanks,
here.
Harry.
We were as well. And Deshaun does have a question. What other things should we be looking at learning around the Kubernetes space?
This is a tough question. I mean,
it's a big question.
I had this, I told it to Nate before. I was actually teaching a Kubernetes class today, and I had a very similar one. And I gave a talk about that with your colleague Tiffany last week at KubeCon, where we said, okay, what are the things that you need to add around a vanilla Kubernetes cluster to make it production ready, and highlighted a couple of technologies in the space of networking, security, observability, to basically make that happen. And when we did the talk, we also realized that there's so much out there which we still don't know yet. So I think with the technologies I've shown today, it's a very helpful start to get insights of what's happening and to make your cluster world more transparent to you. And then, I mean, if you have too much time and want to learn new things, just open up the CNCF landscape and point out in one direction, that you always find something interesting to look into. But seriously, I don't know. It's, on the other hand, it might be too much and distracts us from like spending focus on the actual application development, by just spending too much time on worrying about how to set up the cluster. Yeah, I have a hard time answering that. I'll think about it, and I will tell you in Barcelona if I have to come to any conclusion.
Well, that is a good point. I mean, that's one of those things. If I put my architect hat on, we'd really like our teams focusing on delivering features and functionality. And we really, at least from my perspective, want to treat that as a platform that we deploy to. Is, I'd be a little concerned if my developers were spending lots and lots of time dealing with YAML, I guess. But
right. Yeah, I have a Cloud Foundry background, so that I often think to say, well, I understand what all those components do, but why do we need all of them? And we already have that before? So
yeah. Simon is curious if you're going to be at JConf.
JConf or JCon?
He's got conf in the questions.
I don't think I'll be at. There's JCon in Cologne in Germany. I got accepted to this one. JConf, I don't think so. But I will check it right after this talk. If the CFP is still open, we might have a chance. But you're from Belgium, right? I'll probably be at DevOps Belgium again.
There you go. Yeah, that'll be October if memory serves.
Yeah, sometimes in.
Oh yeah. Oh, JCon. He meant JCon. Yes, indeed.
Okay. Yeah, I'm definitely gonna be there.
Excellent.
So yeah, please talk to me. So what kind of Kubernetes distribution do I run?
Yeah.
I actually try to not run it on my machine at all. I have and consume it somehow as a managed service. For the time, I probably spent most of the time using the Docker desktop and enabling the Kubernetes distribution in there. I've been playing around with K3s. But yeah, especially if you do things like I did before and try to build demos with larger scale distributed applications, you need a very proper laptop. So I much rather try to do some public service, spin it up and put it down again once I'm done. But
sure.
I don't have any particular preference there.
And I agree with Deshaun. Didn't we already have that before? Yes, we did. Comes with the territory, as they say. Well, we are out of time. Matthias, I want to thank you so much for hanging out with us. I really appreciate it. And, fingers crossed, our paths cross somewhere here in 23, if
Yeah.
not in 24.
I mean, Sean and Tiffany have already spoken at my Cloud Foundry meetup here in Stuttgart, so that might make you the next candidate for coming over.
I'm down. I'm down.
All right.
I'm always happy. I remember doing an event in Munich, and I remember at breakfast, whatever kind of bread was being served, there was it resonated with my soul. And I thought, clearly I have some ancestors from this part of the world, because this tastes like home. And yes, please, may I have another? So that's a very comfortable place for me. Let me just put it that way.
All right.
Always happy to come over.
We'll try to make this happen.
And, this occurs to me, I shouldn't even say this right now, but I'll have to try to get you on my Twitch stream to hang out on some random Monday. I'll ping you here offline, but I just have to throw that out there, because it occurs to me that would be a fun conversation, I'm sure. And
yeah, let's do that.
All right. Well, in the meantime, we hope to see you all at our next Golden Path to Spring 1. But for now, we'll call it a day. So thanks, everybody. Cheers.
All right. Thanks a lot for that. Wish you a great rest of the day.